Electrical discharge machining, referred to as EDM, is a stress-free form of machining since there is no direct contact between the machining element and the workpiece. There are three types of EDM commonly used in today's mold-making industry: conventional die sinker EDM, CNC die sinker EDM, and CNC wire EDM. Conventional die sinker EDM machines use electrodes which contain the detail that is to be machined into the metal workpiece. Electrodes are made from conductive material such as graphite or copper. The electrode is placed into the machine. A positive or negative electrical charge is applied to the electrode and the opposite charge applied to the workpiece. One restriction of the conventional die sinker EDM machine is that the burning can only take place in the Z direction. As the electrode lowers and nears the workpiece, an electrical spark jumps from the electrode to the metal. This spark burns the metal, and dielectric fluid is used to flush out the burnt pieces, allowing the electrode to burn uninterrupted until the desired depth is reached. When the burning is complete, the result is an impression of the electrode in the metal. The distance between the electrode edge and the burnt metal is referred to as overburn or spark gap. Overburn typically ranges from 0.02 of an inch, or 0.5 of a millimeter, down to about 0.002 of an inch, or 0.05 of a millimeter. Higher voltages and amperages result in a larger spark, therefore increasing the amount of overburn. To compensate for overburn, electrodes are built undersized. For example, a 1-inch or 25.4 millimeter square is to be burnt using an overburn of 0.010 of an inch or 0.25 of a millimeter. The overburn has to be subtracted from both sides of the desired square. Therefore, the electrode would have to be 1 inch or 25.4 millimeters square minus twice the overburn. The result would be an electrode of 980 thousandths of an inch square, or 24 90 of a millimeter. If a 1/2 inch or 12.7 millimeter circle was desired in the middle of the square, the circle cut in the electrode also has to compensate for the overburn. Thus, the circle in the electrode must be larger than the desired circle on the workpiece. The diameter of the electrode would be the desired 1/2 inch or 12.7 millimeters, plus twice the 0.010 of an inch, or 0.25 of a millimeter overburn. In this case, the resultant circle within the electrode would have a diameter of 520 thousandths, or 13 20 millimeters.